Ready to go. I think I must have killed everybody in my last search session because we've lost a few faces. Upgrading, deploying, and scaling search. Basically, the idea behind this session is just to give you some pointers and guidelines on how to think about upgrading search, depending on which search platform you're already on. So we're going to talk a little bit about not just SharePoint 2010 search to SharePoint 2013, although predominantly that's where we're focused on. But a few little bits of nuggets of information around what if you're running fast search for internet, what if you're running ESP, what if you're on BPOS 365, whatever you might be using. So my name is Neil Hodgkinson. Has anyone been in my search sessions today? So I didn't scare too many of you off then. Okay. And I'm going to try my best not to overrun and get all my demos done. So those of you that have been in my sessions already, you know who I am. I'm a Microsoft Office Division Program Manager in the CAT team, which is Customer Advisory Team. And we're the guys that, in a nutshell, care about on-prem as well as Office 365. So we've got kind of the whole thing to think about. And basically, we drive towards good customer experiences. Things we're going to look at, search overview. You've all seen search overviews. I'm not going to go into architecture again. I'm just going to show 2 slides. That's all, just for those of you that haven't been to a search session yet, just to point out what the architecture looks like now and which bits were responsible for crawl and query, but very, very basic. And then I'm going to start looking at upgrade choices. And here it's a case of, well, what have I got today? Where can I go tomorrow? What can I not do? Am I stuck in a place where I'm really in a bad situation and running on an unsupported platform and there is no upgrade path for me? So we're going to talk about that. And then deployment and scalability. So I mentioned scalability in the last search session, where we looked at things like what do I do if I want to increase my query throughput? What do I do if I want to increase my crawl? Here we're going to look at decisions like, well, if I want to achieve a certain number of documents per second, how many CPU cores do I need and how much memory do I need? So a little bit more technical detail. I've tried to spread it out amongst my various sessions to try and get more people to come, but it doesn't work for this one. And then I've got 2 demos. The demos I've got, I'm going to upgrade a 2010 search service application to 2013 live. That's going to work, hopefully. And just to let you know, it's actually a fast upgrade. Anyone here running fast? No. Okay, I definitely scared those 2 guys off then. So it is a form of fast search service application. I'm going to talk 2 slides about fast upgrade. It's obviously not relevant to most of you. So takeaways, understand the key elements, very basic. If you've been to the sessions, you'll know more already than you're going to hear in this session. And then just basically to give you an idea or to enable upgrade choices, to discuss upgrade choices with, if you're a consultant, you might want to be discussing upgrade possibilities with your customers, or in turn your own internal in-house choices and upgrades that you have. And then realizing scale considerations. So here it's a case of, as I've said already, how many CPU cores do I need? What do I need to think about if I need to achieve 10 documents per second or 50 documents per second through the search service? So to begin with, very basic search overview. I'm not going to give a prize for this. Can anyone recognize that bridge? No one's going to get this. Anyone gets this, you're amazing. No, okay. That's a bridge near my house. Okay. So search engines. Every search engine in the world looks like that, right? Very, very simple. We take indexes, we crawl content, we parse that content, we generate an index, whether that's stored in a database, whether it's stored on a disk, whether it's stored in memory. We have the ability to query that index. We have the ability to return formatted results. If you were in Wayne's session previously, you'd have seen some customized results being customized formatting of results. And then finally, when the user opens one of those results, we end up back at the page we started from that the crawler reached. That's the search cycle. And every search engine, be it Solr, be it Google, be it Bing, whatever it might be, works in this way. What SharePoint looks like in this regard, from a search engine cycle perspective, is very similar. We have our content collection, content gathering processes over here on the left. We have our query processes over on the right with our web front end where we see the results and we click back and we find our content. We end up in a loop where the crawler finds content and then the user at the web front end side ends up clicking on that content and reopening it. So it's the same thing. I promise you a limited number of slides on this. In terms of SharePoint 2013, when we look at indexing, the bits we're interested in is the green stuff here. This is the bit that basically controls the indexing. You've seen custom connectors and the content enrichment service in Wayne's session. The crawl session, or the crawl services, the content processing services, where we're actually connecting our data, collecting our information, parsing it, word breaking it, whatever it might be. And then the on-disk index, where we actually store that word broken, parsed, filtered information. I've added analytics into the mix here, Because analytics is important in crawl. Because analytics allows us to discover links to other content and allows us to do things like building social map of connections between people. So when you're thinking about the search social experience, I know we haven't particularly had a session on social search, but the search social side of things is driven by search analytics. How you interact with your colleagues, how you interact with other people, what sites you visit, what your behavior is. You can think of it almost like a big brother's watching you scenario, where everything you do is being mapped by the analytics engine. And then on the query side, same kind of thing. Query processor allows us to go and discover the content, allows us to bring those results back to the end user. And then again, analytics is involved there as well, because the analytics allows us to modify the ranking and modify the relevance of information. So if a particular document has been clicked 10 times for the same keyword, for example, and 10 isn't a specific number, it's just an example, that 10th click, that 11th click is starting to generate relevance for that document towards those particular keywords. And it's the analytics engine that picks that up and allows us to promote information through the search engine based on user experience. Again, everything you do is being monitored in search. It's like NSA's out there, right? They're after everything. And that's kind of it. That's it for search architecture. In my previous sessions, I went into more detail. So what I'm really interested in is upgrade. And my 6-year-old's favorite character actually in Ben 10, if any of you got kids that watch Ben 10, is a guy called Upgrade. And that's this guy here. And he's pretty cool. So upgrading search to 2013. 2 processes we're going to talk about, and then I'll look at some other things. So SharePoint 2010 search upgrade, very, very simple. Has anyone actually done it? So 1, 2, I know you 2 have. Okay, so it's very, very simple, and you're going to see how simple it is here. It's one of my demos that hopefully won't break. Fast for SharePoint Server 2010 is a completely different animal. If you've got any familiarity with Fast, Fast consists of more than one search service application plus a completely separate server farm, and merging all that information together to produce something you can actually upgrade to SharePoint 2013 is complex and fairly difficult. Upgrade paths that we have in terms of the individual products. Does anyone run anything except SharePoint 2010 or 2007? 2007? WSS3, okay. No one's running ESP or FSIS or anything like that. So in terms of the upgrade paths, there's a number of approaches. These are the fast approaches, if you like, for ESP, FS14, and fast search for SharePoint 14. Basically, you're in a bit of a sticky situation. If you're running pure fast search for SharePoint 14, we have an answer, which I'm going to talk about in a minute. But generally, you're looking at trying to get to SharePoint 2013 as quickly as you can. If you're running legacy legacy fast, then you're in a bad place. You really can't upgrade. You're talking about customized migration that's going to require an engagement with somebody that knows a lot about fast to be able to help you do that. Pure SharePoint 2010 goes to 2013 very easily. And again, I'll show you that in a few minutes. If you're running Microsoft Search Server, then your only approach is to go to SharePoint 2010 and then upgrade to 2013. There is no Search Server platform. And just to expand this out, there is no Microsoft Search Server 2013 version. So a lot of people that use Search Server would have added it on to WSS because it increased the capability of the platform. I don't know if you're doing that yourselves, but if you were, your only answer is to go to SharePoint 2013. As I mentioned in the previous session, consolidation of the number of platforms we're trying to support is part of the mantra towards achieving a single consolidated search platform in SharePoint 2013. So we don't have any, we're supporting this version and that version and the other version. It's one single entity, and Microsoft Search Server, unfortunately, isn't included. If you look at any of the online versions, so the old classic BPOS Lite and BPOS S and BPOS D, Office 365 as we know them today, you don't need to care about any of that. That's all taken care of for you. Is that a question? No. Just waving your arm around. So, the whole concept of Office 365 is you don't need to care about that. There's lots of things you can do now in 365 you couldn't do before with 2013, some of the search schema things that Wayne was showing. But in terms of upgrade, that's just going to happen for you in the background. And hopefully, you won't get a results outage. You should all be good. So in 2010, how do we do it? And what do we get when we do the upgrade? It's very, very simple. The things that are in scope is everything that's not listed there, effectively. So when you upgrade your 2010 search service, remember there's no in-place upgrade anymore. It is effectively a migration. We can keep things like scopes Even though scopes don't exist in 2013 now, we keep them for backwards compatibility. So you can query web services, for example, or 2010 search farms can consume search results from 2013 because we keep a read-only copy of the scopes. Things like best bets, keywords, metadata, managed properties, all that information is retained. The things we don't keep, the search topology. If you've got a 3 or 4 server search architecture today, you can't upgrade it to a 3 or 4 server search service architecture. It goes to a single server and then you scale it out according to what your topology requirements are. And custom code. Anything, custom connectors, custom iFilters, or even purchased iFilters that you might have bought and installed, they're all gone. If you've got Adobe PDF iFilter, for example, or the Foxit iFilter installed on your SharePoint platform in 2010, you can't install that in 2013. 2013 includes an out-of-the-box PDF, what we call a format handler, and you cannot yet override it. There's been lots of queries coming into Microsoft asking if we can, because they like the way the Foxit one works or they like the way the Adobe one works. But as of today, 2013 includes a format handler for PDFs, so you don't have to go around installing things. And then from a content perspective, literally what we do is we provision a 2013 search center at the old URL of the 2010 one when you go in and do your site collection upgrade that Wayne is going to talk about tomorrow. Things that are out of scope, so if you've got an enterprise search center including custom XSLT or custom web part properties, you're going to lose all of that. As you saw in Wayne's session, it's a very different experience now in search. So anything, if you've been writing your own XSLT, just expect all that to go. If we think about upgrading, anyone using services farms, it doesn't seem to be a very common thing in this part of the world, like consuming search from another farm. Everyone's familiar with the concept though? Okay, so if you're consuming search from another farm, imagine this scenario here. We have our 2010 content farm, which is consuming search services from a published search service application. Too many S's. We can upgrade that almost seamlessly as well. And the process for that means you have to do what we call a search first migration. Effectively, you upgrade your services farms to 2013. You would then crawl all of your content in the 2010 farm from the 2013 farm. And then you can repoint the 2010 web applications to a published service application from the 2013 farm. Effectively connect to the proxy endpoint and you consume those services. It doesn't work for everything. Some features don't work. One that we've learned this week that doesn't work, which was quite new to us, is if you're doing search based on tag clouds. So if you've got a tag cloud profile of a keywords, for example, and where it's used, if you start clicking on the tag cloud, in typical search today or the tag profile page that you see in SharePoint, you will see search-driven results based on the documents or pages or people that have been tagged with that particular tag. If you do search first migration, that does not work. Okay, but it's a kind of a temporary point because you don't do search first migration forever. It's kind of a halfway house, right? It's a kind of a staging point because once you've copied your 2010 farm, once you've upgraded your 2010 farm to 2013, and you're consuming from the 2013 farm, you then start to migrate your content, and at that point things start to work again. So once you get your content farm onto 2013, the features start to light up because the 2013 content farm is making the right calls to the 2013 search farm. The 2010 farm doesn't quite understand what it needs to do. Question?
So will it just not work if you upgraded the content farm first?
So if you upgraded the content farm first, that gives you a 2013 content farm and a 2010 search farm. A 2013 content farm can't consume from a 2010 search farm. That doesn't work. That's a specific no, will not work. You have to go down this route. And then when you upgrade your 2013 farm you upgraded the content farm, you end up in this mode that we loosely call 14.5 mode. You're kind of in a halfway house. You've got a 15 version farm hosting 14 version content. So then you go down the route that Wayne's going to talk about tomorrow of upgrading all your site collections, including your search service or your search centers, and you end up with 2013 search centers, 2013 site collections, consuming from a 2013 search farm. And everything's good and everything's happy and it works fantastically well most of the time. And fundamentally, this is what we do in 365 multi-tenant. If anyone went through that process and had a 2010 tenant in SharePoint Online, SharePoint Office 365, we moved you in this manner. This is how we did it. We built a 2013 search farm, we crawled the 2010 content, we repointed the search proxies, we upgraded the 2010 content by swinging you to a new farm, repointing you at the new 2013 search farm. It can all be automated, and it's very simple. If you've got an enormous amount of content, expect it to take quite a while, though. Okay, it's not going to be a quick process, but it does work very, very easily. I know no one in the room is running fast. If you want to go down the fast route, or you know anyone that does, this link is the thing that's your real friend, because the link allows you to download a tool set which allows you to run scripts against a fast search for SharePoint farm. And effectively the way it works is we take key components of the fast farm, such as the fast admin DB, from the separate fast farm. It's nothing to do with SharePoint, that one. The fast query search service application database, and the fast crawl search service application database. Now, fast query is responsible for managed properties and for the query response. The fast crawl is responsible for content acquisition. So we're basically taking your content configuration, your query configuration, and your admin configuration, running some PowerShell scripts and some custom SQL scripts that, yes, they do write access to databases, and they create a kind of a customized, bespoke database that looks, to all intents and purposes, like a SharePoint 2010 Search Admin DB. And then we can take that and upgrade it to 2013. And this is the only time Microsoft advocates making writable changes to any of the databases. And you must do it under the auspices of this particular documentation with these particular scripts. If you go off spec and start doing your own thing, you're unsupported. All right, stick to the rule. Anyway, none of you are doing fast, so you don't need to worry about it. But it's a great tool, written by some good friends of mine. Oh, that's interesting. Let's build that. So think about the actual migration. When we talked about things that are in scope for SharePoint, just about everything's in scope, more or less. In Fast, it's very different. So there's lots of things that are not in scope. Fast is a very customized, driven, search-based search service application. And as a result, a lot of the things are not there. So things you will get, like you might expect to get, crawl rules, crawl schedules, things that you see in 2010 as well. Things you definitely don't get, optional processing dictionaries, pipeline extensibility, customized stuff that people build on top of Fast. All of that's going to get left behind. Okay, there's nothing we can do about that. From a content perspective, the Fast Search Center, as it is today, is gone. Okay, there's no upgrade path for that. You can't upgrade a Fast Search Center to a 2013 Search Center. It just gets destroyed. You delete the site collection, you build a new one. Very straightforward. Or subsite, whatever it might be. So with that, I'm going to try and do this for real. So you've seen my track record so far with demos. Okay, I'm about 50%. Okay, and I'm trying not to overrun on this session. So let's see where we go. Okay, so we're going to do it through PowerShell. The scripts that we use to do this, if I've got them on this machine. No, okay, I don't have them on this machine. But what I've done here is that gallery, that TechEd gallery link that takes you to the PowerShell. What I've done is I've basically ran those scripts against a fast environment and produced a database that looks like a SharePoint 2010. So this, forget the fact this is using a fast form of fast DB effectively. This is pure SharePoint 2010 at this point. So the key thing we need to do is we need to get our SharePoint 2010 database online in SQL. Otherwise, there's nothing we can do with it. So we've got to drop to the SQL server. Of course, no one really installs a SQL server on a DC, do you? Hopefully not. So I can restore my database. And I need to call it the same name as I've got in my script. So bear with me a moment. And I'm calling it just Search Admin DB. So, ooh. And I'm going to restore from a backup, which is the net kind of output from running all the scripts. The scripts take a long time to run, which is why it would literally take the whole session to complete the scripts, which is why I'm not doing it here. So basically, I'm going to back up this database, and that should be it. And we should have our database in here. So far, so good. We have our Search Admin DB there. So I'm going to use that as the target for my actual upgrade to 2013. So I'm going to go to my 2013 farm. Inside my 2013 farm, I have my test search service application I just deleted. And let me just disconnect and reconnect. So This should be gone now when this refreshes. If it refreshes. Just thinking about it. I did a test run on the demo just before the session, so I wanted to make sure it's going to work for you. And clearly it's broken something else. Well, let's have a look. Let me just reopen Central Admin. It's probably just timed, just a bit slow on the app pool's probably timed out. So let's give it a second. So what I'm going to do, I'll just show you the PowerShell while we're hoping for that to load. Basically, I'm going to run some PowerShell, which is connect just some variables to show what my search service is going to be called, the name of the database, and the database server. I'm going to create a new services application pool. I'm going to call it Restored SharePoint Search Services. There's the app pool identity. Now, I would normally, if I hadn't already done it, then also create a managed account for the search service application. Okay, so if you're familiar with SharePoint's managed accounts, I don't need to do that in this case because it already exists. I keep creating it and deleting it, so I'm just leaving it in there. So what I'm going to do is, yeah, so I'm going to get the managed account identity rather than create a new one. And then literally all I need to do after that is start the search service on a box where I want to use, when I'm going to basically start the administration service for search. And then I restore the search service application targeting that database. So most of the service applications out there, when you do a migration like this, you run new or upgrade for the search service application. That's your PowerShell. With SharePoint, with search, we decided to use restore instead, okay, just to be different. So let's hope that the app pool's come up now, and it has. I'll just check I don't already have that service application. And you can see I don't have a search service application in here. That one did get deleted. And fingers crossed now, I'll go through this step by step. So I'll add my snap in, set my variables. These are my app pool names of my account. I'll get the managed account. Nothing's failing so far. I'm just going to validate. I'm no PowerShell wizard, so I definitely have got the right account. And then I'm going to create a service application pool called the Restored Search Service. And then once I've done that, I'm going to get the host. So that the machine I have is a single server, and this is basically the machine I'm going to start the search services on to be able to restore and configure that. So I've got the host. I can start the service, and then I'm just going to get the identity, get the service, and you can see there it's saying the service is provisioning. So this is equivalent to going into Central Admin, Services on Server, and clicking Start on the search service, basically. What I want to do is just refresh that, and then get it again. At some point it will come along and say it's online, hopefully. Yeah, we're online. So I've now started the service, so I'm in a good state to actually do the restore. So the restore command, restore SP Enterprise Search Service application. I provide the search service name. I provide the database server name, the actual name of the admin DB, I want to restore from, then the app pool, and then the service instance where I'm going to actually operate the search service. So if I run this, it doesn't take too long, it will take a couple of minutes. And what we'll start to see in here, it does take, depending on what's going on, it might take longer than necessary, but you can see the form of fast search service application we built. You can see its state is upgrading. So it's basically reading that database, validating what's in there, and confirming that it can convert it into a specific 2013 format. Very, very simple. We continue to do this. It'll either say upgrading or error at various times. It does take a few minutes. If it seems to take a long time, I'll switch back to the slides. But what's going on in here, if I look at the database server, you can see the database is being created. Okay, so it's going to take a few minutes. I'll switch back to the slides and we'll come back. We're going to reuse this search service application we've just upgraded to actually scale out. So we'll check its state when we come to the next demo. I'm determined not to overrun on this session. So let's just flip back to the slides. We'll come back to that when it's completed upgrading, and I'll just create a proxy for it. So that's pretty straightforward. It's, what is it, 10 lines of PowerShell? There's more comments in there than there was actual PowerShell. So let's think about deployment and scale. So 2 ways to deploy SharePoint search. Yeah, 2, really. Central Admin Wizard. I don't mean the farm configuration wizard, because nobody ever runs that, do you? No, right? Not even in dev environments. So Central Admin Wizard, create service application, fill in your parameters, and off you go. That's a reasonable way to do it if you want a load of GUIDs in your search DB names and you want kind of the out-the-box configuration. Or you can do it in PowerShell. In PowerShell, you get total control. So where do you want the services to go? What do you want to call them? Which servers do you want those databases to reside on as well? So it's the right way to do it. Very, very simple, effectively. Even I can do it. And then we think about scalability. Think about scalable and in terms of the directions of scalability. We scale for size, we scale for performance, as I mentioned in the session earlier today. Think about content volume and item count. The number of items affects how many partitions you need. The number of partitions you have counts how many index servers you need as well. So it kind of affects the number of boxes. In terms of queries per second and query load, how many query servers you have, plus things like how much memory those query servers have. How many pre-run queries can we cache? How many security ACLs can we cache? So we don't have to constantly go back to the index when we're doing security trimming. What's the crawl load? How many documents per second do we want to run through this environment? These things matter. It depends on what you're doing. Some people don't care. If it's a small departmental SharePoint implementation, we get what we get. We don't care. If it's you're deploying it for a customer who has a critical business need for content freshness or for search result delivery, such as publishing sites using content search web parts, queries per second is really going to matter to those folks because it's critical to the actual page render times and critical to their business. Thinking about multiple workloads then, so the collaboration, the websites, Exchange, as we mentioned previously in some sessions, and Office 365, the way you build it is you have to build your search experience towards what the needs of the business are, as we mentioned previously, the publishing site, the collaboration site, and it really affects what you build. With search in 2013, we can scale it any way up we like. So every single component can be scaled in one way or another. And you can scale them up in terms of more CPUs and more memory, faster disks, bigger disks, or you can scale them out. And whichever way you go, there are some you have to scale out, for example, item count for indexes. There are some you can just scale up, so query processors and documents per second. And I'm going to try and give you some of the numbers. The key thing to understand is the drivers. So when we think about some of these components, the query processing component is, as we've said previously, it's the thing that's delivering our results. It's sending a request to the index. Those items are coming back from the index, and the query processor has to then convert that into using the right query rules, doing the security trimming. So it's got heavy lifting to do. So the things that matter, how many queries per second do we have? How many query transformations? Wayne, did you do query transformations in the last session? Yeah, so query transformations, how you're going to change the query or modify the query that goes into the search engine. Are you going to affect that query when it comes back out? All these things matter. The more of those you have, the more power you need in your query processing component. So the guideline, 4 queries per second per CPU core. That's actually quite reasonable. Microsoft's internal intranet, search engine, MSW as we call it, the query rate on there is about 5 queries a minute. That's 100,000 people and a 30 terabyte corpus, 5 queries a minute. So 4 queries per second per core. You don't really need massive CPUs in order to deliver this. But obviously, an off-the-box commodity server is going to give you, a reasonable number of cores to make this work. But our business need for MSW is quite low. We have all sorts of other portals for that. Other driving factors, network load, number of index partitions. So the servers are always talking to each other. The indexes or the replicas are replicating content backwards and forwards across between the partitions. So network becomes critical. You can't connect SharePoint servers together with 10 megabit networks. It really isn't going to fly. And then obviously the size of those queries. How big are the actual queries I'm submitting? How many results am I going to get back? Have I modified the batch size for those results? All those things become a factor. This is an example there, 20 index partitions. That's a lot of index partitions. Typically, we'll give you 200 megabits per second in and 100 megabit per second out. If you've got 100 megabit networks, you're almost saturating your inter-server communication here just with search. And that's before you even do anything else, like crawl or any customizations or anything. For the index component, think about CPU load. So there's a lot of power being used in the index component, especially in terms of queries per second. The more items you have in the index, the more work it has to do. The bigger the files it has to pass. So the more cores and the more powerful CPUs you're going to need. So there's an example there, 1 million items, 5 queries per second per CPU core. Again, that's quite high. It's not high for an internet-based application. If that was running on Dell.com with people browsing their website that's a search-driven application, that's very low. Okay, they need a lot more than that. But for your regular departmental intranet, that's probably more than enough. So a single query component, a single index component with, of course, you'd have a second one for high availability, is probably more than enough running on a quad-core, 8-core processor, whatever the standard guidelines are for SharePoint, as Wayne's going to talk about tomorrow when he does upgrade. And then disk load. Index servers, as Victor pointed out in the session this morning, they've moved some of their indexes, so they're running on SSD drives. The disk speed for your index is critical, absolutely critical to the performance of the index, because you're passing very large files. That big search service application I mentioned in my previous session, those have got 20 servers with 500 gig files on each server. It's an enormous index thing. So having fast disk is critical to that scenario. You know, would you run it virtualized? Depends. Depends what the expected query load is. You know, if you can get away with low query load, then you may not need that level. But if you're looking at a .com site or internet site, you will want fast disk to be able to deliver fast query performance. From an IOPS perspective, in terms of crawl load, these are the kind of things you're looking for from your disks. So 32 to 512K bytes, query load of 10 million items. If you're running high queries and high crawls, so you think about your internet presence, where you've got lots of content maybe changing frequently, you've got lots of queries coming in from end users who want to buy things off your retail site and you're constantly changing things, then you're doing this thing called index merge. Can anyone tell me what a master merge is? There's a prize up for this one if someone can tell me what a master merge is. Merging them together? That's close enough, yeah. Are you going to TechEd anyway? To SPC anyway? Or do you want? You can have a bag of swag then. Well, there'll be a more difficult question for the robot. So the key thing to remember with the index is, you remember we went back to the diagram right at the beginning, and we saw the crawl components on one side, and we saw the query on the other, and the index in the middle. So the index gets hit from all corners. If you're querying, it gets hit. If you're crawling, it's being updated. And then you have this thing called master merge or index merge, where the index has to constantly, almost, if you think about a defrag process on a hard drive, it has to defragment itself in many respects. So it merges the new content in with the old content and generates new fresh index files. That's very heavy on disk I/O, very heavy on disk space as well, because we have to generate new files on the disk before we can delete the old ones. So you remember SharePoint had these metrics around, you need 2.85 times the size of the index for your disk space. This is the reason why. It's because we need to merge these files together. And from an indexer perspective, that can all occur at the same time. Okay, at any one point in time, all three of those things could be happening at once. So it's critical. The disk is critical. So SSDs is a good idea if you can afford it.
What about disk fragmentation? Should you run disk fragmentation?
I wouldn't run disk fragmentation in a live environment. Disk fragmentation can be running a disk fragmentation can be beneficial, but the index merge will always seek the biggest continuous disk space anyway. So I would never not do it, but it probably doesn't need to be done as frequently as you might think. Plus, the index isn't necessarily one big file. It's actually built up of lots of small files. So fragmentation, yeah, defragging helps, but not, I wouldn't say. Yeah. Okay, and then from a crawl component perspective, the crawler's doing the heavy work in terms of going out, reaching content, and bringing it back to the search service. So things you need to think about, driving factors, what's my documents per second, what's my link discovery rate? So if I'm discovering content and I find a connection to something else, I then need to go and follow that connection and find the next thing. So lots of things going to happen inside the crawl component. Network load is simply downloading items, plus it's not only downloading items from the source, but items have to be passed to the content processor as well. So there's another network impact there internally within the SharePoint farm. But typically what you find from a network load perspective, it's very easy to saturate a network with a SharePoint crawler. I mentioned in the previous session, denial of service attack on sources is very easy. SharePoint crawlers are great for that. You want to take down something else, you want to hurt somebody, use a SharePoint crawler. You don't need a script kiddie anymore. Just use a SharePoint crawler. And in terms of downloading content, you're pulling those files. They have to be actually collected from the source pulled down to the crawler and passed over to the content processor. We unfortunately don't have a kind of distributed crawl system. We can't communicate to a crawler on the other side of the world and just send me the updates yet. Hopefully, we never know. But right now we can't do that. So you're constantly pulling files over the WAN, for example, or over the LAN for changes. And then disk load, we're writing to disk all the time. Easiest way to cripple a crawler, don't use antivirus exclusions, because the temp location where we store the files that get pulled down, if you imagine you're pulling files down at the rate of 10, 50, 100 documents a second, and you've got AV set to scan on access, you're just going to cripple the crawler. So just be really careful with that as well. I'm not saying don't run antivirus. You should always run antivirus, but make sure you configure it correctly. Victor?
Tip on that one, default location for where they download software is on C drive.
Yep.
And I've seen several times where they're running on space on C drive.
Yeah. So as Victor was saying, the default location for disk for temporary crawl content is the temp location of the service account that's running the crawl component. So make sure you've got that kind of enough capacity there. And, I mean, in theory, as long as you're crawling content, it's hitting the disk and it's being passed over to the content processor fast enough, it's being cleaned up at the same time. So you're not going to constantly grow this thing. If your content processors, you don't have enough of them, you get a bottleneck, then expect that to grow. Or if your content processors go offline, but your crawlers are still running, you're going to start to accumulate content in that folder. So you've got to be very careful with that. Speaking of the content processor, again, CPU load. So the content processor is loading iFilters, it's loading format handlers, it's parsing documents, it's doing a lot of heavy file work. And sometimes those files can be quite large. It could be many thousands, if not millions, of small documents. It could be hundreds, tens, thousands of very large documents, media files. It could be whatever kind of content you've got stored in SharePoint. So size and complexity becomes an issue. And then the network load. As we said already, you're transferring files from the content processor, from the crawl server to the content processor. There's a network connection there. Then from the content processor, it gets passed over to the index. Again, there's a connection there as well. So you constantly, the search traffic within a SharePoint farm, especially if you're crawling, is huge. Okay, because the likely is you're crawling and querying at the same time. So you can get a lot of network traffic. From an analytics perspective, analytics is the one thing that where you can, if you're on a POC and you don't need analytics, you just want to see what how SharePoint works, turn this guy off. You can't not provision it. You have to have an analytics component, but you can turn it off once it's running. Okay, so you don't need it to run, you can stop it. However, if you're running it for real, things to think about are number of items and the activity on your site. So if you've got a very busy site, a very busy web application, you're constantly writing events to the event store. The analytics process is constantly running effectively. Disk, so when your web front ends are collecting usage files in the logs directory, those usage files get uploaded via the search service application proxy to the analytics component. And then the analytics component has to deal with them. Those files can be quite large. You know, I've seen them kind of 10, 15, 20 meg, 10, and some 2, 3, 4, 5 gig, depending on the amount of activity in the file. Question? Yes. So everything, so the question was, does it track social activity? So anything that you do inside SharePoint that involves an event, and you can customize as well, you can write your own custom events, gets picked up by this guy. So if it ends up in the usage logging DB or in a usage file on the disk, the analytics engine can process it. Network load again, lots of files going on. The more analytics processing components you have, the more places those files have to go. So the analytics processing component, they all receive updates from all of the web front ends and from all of the events. So there's lots more traffic going on the more of them you have. You sometimes need more for as your environment grows. We look at some of the scalability factors. But generally, the more you have, the bigger network you also need because you're generating more traffic. Then the final component really is the admin component. We don't care about this one. Okay, it's very, very little CPU and network overhead. Practically nothing on disk because all it really is a WCF endpoint. There's not a node runner process. There's nothing really complex going on inside this guy. However, as you add more components and more admin components to the search service topology, you will start to get an increase. But by comparison with the other components, it's negligible. You don't really need to factor it too much into the equation. So this is a good slide. This has appeared in 3 sessions today. It's a great crib sheet. Those of you who saw this earlier, it's a really cool way to kind of think about where you match components up. So storing, for example, search admin with index is not an unreasonable thing to do. You might not necessarily do it. But the way you can kind of think about the various components here, this is kind of a, if you've got anything you want to take away from this session, this is the slide you want. Think about how you mix and match components. And again, the same one as we saw earlier. So those of you who have seen this before, thinking about if I've got components that are heavy disk utilized, I don't want to put another component that's heavy disk utilized on the same machine, because I'm just increasing the complexity and increasing the resource contention. So mixing search admin with crawl is a good thing. Mixing content processing and analytics is a good thing, because they have different characteristics in terms of use of resource. And this may change over time. You know, we might start to say things like, well, index and query processing, maybe it doesn't need to be two separate components anymore. Maybe we'll think about merging them together, because we always say put them together anyway. Maybe we think about where's the right place to put them. Is it on the web front end? Is it on an application server? See Victor's session from this morning, so it depends. There's lots of things to think about, but fundamentally, if you've got 3 stars in the column, don't put it on the same machine as a column as another component with 3 stars in the same column, because you're just asking for trouble. Database sizing, again, we saw this one this morning. So really these are just metrics. These are all available on TechNet. If we change any of this, it gets updated on TechNet, so you can go and find it out there. And as I said this morning as well, same thing for scalability in terms of size. If you need to build a search service application, or you're going to modify a search service application, your customer rings you up and says, search is crippled, we're having major problems, get this guidance first before you go on site and start saying, well, you need another one of these, or you need to move this away from that. This is the guidance you need to make those decisions. And the final one in terms of performance, so full crawl time, result freshness, thinking about things like, okay, well, I want to deploy an environment where I'm going to get fantastic crawl freshness. So the guidance says for SharePoint, even if I have 100 million items, I only need 2 crawl components. But I want to make sure they're not sharing resources with something else. So make sure they're separate, doing their own thing. If you can afford it, if you've got the hardware, put them on separate machines. So kind of think about scaling up like that. So for freshness, improve your crawl time, add more crawl databases or crawl components. Crawl database we discussed in the previous session. For time to deliver results in terms of query processing, actually getting those results back to you, you can have additional query processors, extra partitions. The more partitions you have, or should I say, the more replicas you have within a single partition, the more copies of the index you have, the more parallel queries you can make. To think about it as a simple analogy. It's not quite a linear relationship, but that's a simple way to think about it. And they all stand to reason. The more things you have, the faster things should go. But there will be a diminishing return and a cost exercise to go with that. So with that, scaling out the search service application. So we're going to go back to my machine, and fingers crossed that upgrade's worked, and we'll have a search service application that I can actually now scale and add some more components to and do things with. What I'm going to do, we should have right now this guy. So SharePoint Server 1 with the 5 search components on it running under the search host processes, the node runner processes, and the crawler here, who's our MS Search Exe process. And hopefully we're going to see that. And I can't see it, my screen's gone blank, so I have no idea whether this has been successful. So we're going to find out. Okay, and what we're going to move to is this. Okay, so we're going to go from a very simple scenario. We've done our upgrade. As I mentioned, search topology isn't included as part of in scope for an upgrade process. So if you started with 10 servers, at the time you upgrade, you're going to have 1. Okay, so then you need to scale out. Now, don't look at that slide and try to say, Neil said build it like this. This is purely an academic exercise of how to move components around, okay? You would never do that in real life, okay? You'd just be killing yourself. But I just want to kind of show you how simple it is and how easy it is to move these things around. Oh, sorry. Let's get the demo going. And I'm probably going to run short, which is cool. Okay. So we've got our databases, as we saw earlier. If I go back to my search service application, we can see it's started. So that's a good sign. We're getting there already. So the last thing I needed to do as part of the upgrade process was to provision a proxy. Because without a proxy, we can't use it. Okay, we can't connect to it. So that's the first time I've done this demo with no red lines, no red writing on it. That's pretty good. So we've got our proxy, we've got our search service application. And if we go and have a look, when you do this, now we've got about 10, 15 minutes while we've been waiting for this to provision. If you do this for real, what you'll see is, as the service comes online, even after it says it's done, and then you can go and create the proxy. If you do that kind of instantly as soon as the service comes back and says it's done, this middle line here with all these little green ticks, you'll see a few green ticks, you'll see some yellow triangles, you'll see some red circles with X's in. That's because the individual components themselves haven't managed to load yet, and they haven't reported back to the admin database, the admin service, that they're online. So just keep refreshing, and eventually that'll come up. Doesn't usually take more than a few minutes. So we have our search service application. We have no GUIDs in the database names, which is always a good thing. So your database, your DBAs are going to be happy. And obviously, I just kind of let this go based off the admin DB name that I had, but you could do this your own way. So what I need to do now is scale this out. So I need to drop 2 more servers in here and add all those components and actually remove one component and push it onto another server. So again, we can do that through PowerShell. So we have our same approach. Here's our search service, our admin DB. This is the name of my application pool and the service account. And then I'm going to scale it out. And the way we do that is we connect to the search service application. This is something I'm going to do extra, okay, which is an export. Exporting the search service topology generates me an XML file which represents the current topology of the search service application, okay, which means I can always go back. I can rewind, okay, if I don't like what I get. So I'm going to try and build it. We've got time. I'm going to try and deploy this and make it scale out. While it's running in the background, we'll do questions, and then I'm going to try and rewind it. So we didn't like what we got, we're going to blow it away. So the key thing is, I'll just get it going. Now, last time I did this demo for real life, I got to the last line of the demo, went to press F8 to run that one line of PowerShell and hit F5, right, and ran all of it again. So it didn't work. So I'm going to be very careful this time. In fact, I'm not even going to go anywhere near F5, the F buttons. So I've got my variables that I need. Now we're going to scale out. So I'm going to export the topology, get the service application, and export the topology. That will give me, down on disk here, this file. We just have a quick look at that. And what you can see is an XML representation of the components that we have available in the farm right now. Okay, so it's relatively simple. And you can see, obviously, here's our databases. Here's all our components, tells you what server they're on, and so on and so forth. So okay, it's a worthwhile for an extra piece of documentation, if nothing else, for how the search service used to look before you ripped it to pieces. So then I need to start the service on my expansion servers. So I'm going to move to SharePoint Server 2, SharePoint Server 3. So I start that. I get the services, sorry, and I start them. I'll then check the status. So you can see they're provisioning. Let me just, is that all readable for you? So they're both provisioning still. Eventually, I can't do anything else till they come online. And it's just going to take a few minutes, hopefully in less than a few minutes. What I'm going to do after these have come online is I'm going to get a copy of the active topology. So that, like you did with 2010, if you'd done this in 2010, take the current topology of the search service application and then clone it. So I've got a running search service application now, and I'm going to clone that application and then make modifications to the clone before then activating the clone and deactivating the live one. And this can all be done without loss of search service. So there's no loss, you've not got downtime while you're doing this. That's something Fast could never do. That's a good thing that SharePoint helped them out with. So there's my services, they're online, so I'm ready to go. I can start to interact with those services. So first thing I'm going to do is get the active one. Then I'm going to take a clone of it. So if we look at the two here, pretty simply, we can see the topology ID when it was created just now at 4:37 in the morning UK time. And then we've got our clone. So our clone is inactive, and it's an exact copy. If I was to go in a bit deeper and pull out the topology, all the details, you'd see that they're identical, except with different GUIDs. Once I've done that, I can start to add various components. So I'm always working with the clone now. I can't add a component direct to an active topology. It won't allow me to. So using the clone, which has our ST here, I can add a crawl component. So there's my new crawl component 2 on this server. I can add a new content processor, again, on crawl server 2. And I'm going to add 2 query processing components, one on server 2 and one on server 2, one on server 3. And then I'm going to put another search admin service on, because why? HA. Okay. Have you got a ticket to SharePoint conference? No. Okay, you've got one. Okay, it's yours. I'm saving the big box for a good question from you, not from me. Okay, so now we've got the search service instance. We've got our components done. If I was to do a check on that clone topology now, I'd see the count that it changed to all those components. So now I need to scale out the index partition. So I'm going to add additional replicas of the original partition that we had. The index partition 0 at the end denotes partition 0. It's the index number if you like. If I was to make it a 1 or a 2, I'd start to add additional index partitions. And then when I activate the topology, if I had a single partition with, say, 500,000 items in it, those items will be then distributed across multiple partitions. So it's a way to refactor your search index, if you like. So I'm going to run that. I didn't run that before, so there we go. There's my two index components. And I can do all kinds of other things in there. I can specify parameters like where I want the index to be. You know, I can specify the default file locations and things like that. So this is just a demo, so we're sticking with that. So in this case, I want to remove the analytics component that we had and move it somewhere else. So in this case, I'm getting rid of it. Yes, doesn't like the idea of you deleting things. And I'm going to add it somewhere else. Now, it's an analytics processing component, so it's stateless. I'm not losing any data by doing that. I'm just moving it to a server where it's more suited based on the topology requirements that we have. I can add some crawl DBs. Now, these take a little bit longer because if we go into SQL, I'm doing really well for time, so I'm quite happy. We should see when this refreshes. Yeah, there's our first one coming in. So we generate a crawl store, and obviously when it does that, it has to generate the schema, so it takes a little bit of time and set the permissions and everything for it. So it's not quite as quick as adding the other components. Oh, sorry. When you add databases to the search topology, it adds them directly. It doesn't have to wait for you to activate the topology. If you add a database, it's going to appear straight away. So that was the first one done. The second one shouldn't take too much longer. Just checking SQL. Come on. There, crawl store 3's appeared. So I've now got 3 crawl DBs. So I can crawl up to, does anyone know the number? How many items can I crawl with 3 crawl DBs? 60 million. So the capacity planning guidelines is 20 million items per crawl database. Okay, this is getting pretty big now. And then, so they're both done. I'm going to add another links database because I've decided that I'm going to generate lots of entities and I'm going to do lots of connections between my items, and I'm going to find lots of anchor. I want anchor crawl processing to be quite distributed. And then the last thing I do is set the enterprise topology to my clone topology, which basically says activate the new one, deactivate the old one. So normally if I had an index with like millions and millions of items in, this would take an inordinate amount of time. Okay, well, it moves data around and refactors content. You think about if I'm moving a search index that could have gigabytes of information in from one server to another, there's a file copy operation to take place. So it can take a fair amount of time. So I'm just going to execute that now. So that's going to start to run, and it'll take a few minutes. What we'll see, if we see in here, we should see a message that says something like a different topology is currently being activated. Okay, search will still work. Absolutely fine. Your querying is still going to work fine. So this is going to take a few minutes. So any questions while this is running? This is pretty much the last thing we're going to do. So.
I've got a question. If we had a scaled out search topology already and you wanted to modify it,
Okay.
and you say it's going to take quite a long time for it to reconfigure
Mm-hmm.
that new topology and activate it, what's happening to the existing topology? I mean, are crawls working in the background, still providing updated content, or is it just going to be
So your crawls will pause. Okay, the minute you click activate, your crawls will start to pause because we don't want you adding new content to an old index, effectively, which is what you'd be doing. So the querying is going to work against the old index while we build you a new one. So if you imagine a scenario where you've gone from, let's say you've got one index partition, or 2 index partitions, okay? So 2 servers, 2 indexes, 50% of the index on each. And you're reaching disk capacity, you want to go to 3, so you reduce them individually. The way that has to work is we basically will split each of those copies into 3. We'll make a new copy of the index, split it into 3 pieces, redistribute those pieces on the 3 servers, merge them together, and then basically the query processes will then be pointed to the new copies. So that original copy is still there, but we won't allow you to update it because those changes won't get replicated to the new copy. So crawls will pause while you do this. Okay? But in terms of querying, no problem at all. You know, if you'd be the very unlucky user that just happened to query the service just as those components were deciding to point from one server to another. You know, it's effectively, think about, you know, moving over a load balancer almost. It's that quick. Okay. Any other questions? Or you're waiting to see my demo spectacularly fail. Yeah, go on. No. In a nutshell, no. I mean, you can't, when you say migrate over to Azure, as in put the analytics bit in Azure and deal with everything else somewhere else. No. So we don't support distributed topology. Your search service, in fact, your entire SharePoint farm has to exist in the same logical data center. So you can't do that. You could push all of it to Azure, in theory, once you ironed out the performance characteristics, but not just one component of it. No. Question? That depends on how critical search is to your environment. So if you're going to go through an upgrade process, if you're going to rescale, it's the rescale process, right? So imagine if you've already got a very rich search service application with managed properties in there, you know, crawl properties mapped, perhaps customizations, then the last thing you really want to do is destroy that. You know, if you get an error, try and troubleshoot it. Sometimes those errors could be catastrophic. Okay, I can't say I've never done this and it's not failed amazingly. If you're in my previous session, I mentioned that huge search service application with 20 partitions in it that we had. Trying to make that work took about 15 attempts to get from what was a 4-partition index to a 20-partition index. And just that refactoring process, you get timeouts, you get all kinds of problems going on. So try and avoid deleting the search indexes or deleting the search service application. It would be my kind of last resort. Sometimes what I've seen is I've left it broke during refactoring, but I can still query. So I'll just create another one alongside it, assuming I've got enough disk space and enough places, you know, per component placement. Build the new one up, migrate the search settings across. In 2010, Victor wrote Victor enhanced a good tool to become a great tool. For migration of search settings between search service applications. In 2010, it worked amazingly well. I don't know if we're going to get a 2013 version. No. But you could migrate the settings. Just point it at one search service application and pull them all over. So the managed properties, the crawl properties came over, scope configuration. So you could literally build a new one. And that's actually how we ended up doing the 20-partition one. We just built a new one out, scaled across new servers, and then deleted the old one. It was the only real way to do it. 2013 is supposed to be more resilient to that kind of thing. Don't delete your search service application if you can avoid it, is the message. Any other questions?
The performance, the difference between 2010 running out of, say, iFilter or the Fox that compared to the out-of-the-box 2013 search?
I am not aware, you mean for PDF filtering, basically? I'm not aware of anyone that's done any specific testing on that. Back in the day, Jay Lee wrote an article on his own personal testing of comparing Foxit with Adobe. I know Adobe have released a better product since then. The PDF filter that we have in SharePoint 2013, I mean, in the farms I've dealt with in online dedicated space, I can't say I've noticed any degradation, but I haven't done a direct comparison. I really couldn't comment. But I would be very surprised if it was amazingly better or indeed amazingly worse. It's probably comparable, which doesn't really answer the question, but it's the best I've got, I'm afraid. Any more questions?
For analytics process, can we just switch on for a certain group of people?
No, no. Exposing analytics data, if you wanted to say exclude a user from their social experience being pushed into analytics, you'd have to turn off their social experience.
Not at the user level. I want to process only a certain group of users, only the HR users.
No, no. You're going to get whatever people do, whatever everybody does. There's no way to interface with the analytics component and say only handle a certain amount of users or exclude analytics from here. You'd have to, from a social perspective, you'd have to remove their entire social experience, and I've just run out of time. So that's kind of one of the things. Stop. Let's check the demo, and then we'll see what happens. So we're running, that's a good sign. And it's worked. It's my best demo of the week. So we've distributed across. You can see our extra databases, and you can see how easy that was. Now that's an index with no content in it. So it's a very short, it didn't take much time at all. But you can see how easy it works. If I'd been doing that for real, I'd have had users testing, querying all kinds of things as well at the same time. I'm chuffed. I'm really pleased. Okay, so to wrap up, search architecture, we've looked at a little bit. We've done 3 search architecture sessions today. We looked at upgrade process and scope and scale out process and decision making. So those numbers and those metrics will allow you to have that kind of conversation and that discussion around what you do with your own deployments, what you would do with a customer's deployment. So with that, any more questions? And I'm looking to give this thing away. So it's got to be a good one. That's okay. Victor's here. Mm-hmm. So the crawler, the configuration for like the registry settings for max download size, the registry settings don't apply anymore. But then again, SharePoint 2013 can also crawl significantly larger documents. So we don't have that, we won't hit a 16 meg limit and suddenly stop indexing or reject a document. It's much bigger. Yeah. That was a good question. You've just won yourself a robot. Anyone else? As long as you've not got one. Because somebody got 2 earlier. That's just not fair. Any other questions? Or you're going to go now because the robot's gone. Yep. As in, so the question was, in crawling, you can only specify the top level or the root of the web application. You could specify a site collection if you wished, but what's the aim? To just crawl one site collection, or do you want to add multiple site collections? Okay. Yeah, so the way the search engine works, we want you to crawl from the root. The site data web service that the crawlers hit understands things like hostname site collections. It knows how to enumerate them, so you can enumerate all the content. If there's specific content you want to include versus exclude from the crawl, still crawl the whole web application, but use crawl rules to exclude that content. That's the right way to do it. Okay. Anything else? Okay. Jolly good. Thank you very much.